32 is what we were going to do. Is that right? Sound right?
Yes,
Okay.
we were attempting to do 30 with the bearings.
Yeah. Do you want to do some more work on 30, or do you think you got it figured out? Okay. 31. 49. 32, I guess. Says the child leaves home, arrives at a school after walking 6 blocks south and then 8 blocks due west. So she goes, I guess this is home. She goes 6 blocks. And then 8 blocks. And then she's at school. And then it says the bearing of the child's home from the school. So what they want is from the school back home. What's the bearing? And the bearing is always from north, right? So, and it depends on that angle. And you know, if I give you something like this, it'd be, I would establish the angle. I would say that the angle is 40 degrees, or maybe I would give you this angle is 60 degrees or something. But that's what it says. It doesn't look like 40 degrees, but that's what it is. So the bearing is going to be north 40 degrees to the east. Remember, you always go north and then you say how far it is over. So that would be the bearing. Now I'm going to do a problem that has azimuth. And next, but it's this problem 33 is where it explains azimuth. It says an azimuth is a line if you go north south. The angle of the line segment makes with the north-south line. So what you do is this is north, and the azimuth is always measured from north, and it goes this direction, and then wherever the so whatever this angle is right here, this is going to be the azimuth. So there's, in trigonometry, there's, you got bearing, you got azimuth, and then you got one other thing that you measure in terms of angles. You're always measuring from this point, this direction, positive. So you got to know whether you're doing bearing or azimuth or whether you're doing a trig angle. So it's azimuth and bearing are used in navigations, and then in trigonometry, they're measured angles from the horizontal.
From the x-axis.
Yeah. And always from the positive of the origin out to the right. And then it goes negative when it goes, I mean, it's going to go counterclockwise, negative is clockwise. So you got to kind of know. You got to kind of know what it is. I always tell my, you know, I have center pivots on my farm, and it always, I got one that says, where do you want the pivot to go to stop? Do you want it to come back from that or go beyond it? And I got a draw. I got a center pivot that right out over here, there's a big draw, and I don't want the pivot to go into it. So I always got to figure out, I always have to figure out, well, now, how is this measuring this angle? And what's it calling it? So, you know, I got to remember that 90 degrees is what I'm going out here, and then I'm going over to someplace in the 30 degrees. And I don't want to tell the pivot to go any place in that region. Because if I do, I'll bust it to pieces. So I got to kind of remember what direction, and I got to remember, because I have taught trig, I got to remember that I'm going, you know, I'm going from north to the right to get to 90, not north to the left to get to 90, or from horizontal up. And then it takes me a little while sometimes to remember what to tell it where it's at. You know, if I want to have it stop over here, well, what azimuth am I stopping it at? Because I make errors and kind of don't get things exactly right. And I have gone back and checked it to make sure that I told it to do what I wanted it to do. Okay, so these are the azimuths we're going to convert. 36A, and so it's 163 degrees. So we're going to go from a north-south line, and we're going to go from here, we're going to go around 163. So it's going to give us it's a point between 90 and 180. And it says to I gotta think about this. What do they give us? They want to convert to bearing. So they want this bearing, and then they want, you're going to have to do this angle, right? South, so many degrees east. So how are you going to get that? That's going to be 180 degrees minus 163. I'll do it 163. 17 degrees. So the bearing of that line is south 17 degrees, and that's east. Correct? B part of that. It's saying azimuth is 241. So if we're now 241, straight south is going to be 180, and then off to the west is 270. So what this is, it's an azimuth in this vicinity right there. And let's see. So what I have is I'm gonna have to figure out this one, right? So what I'm gonna have to do to get that, this is 241, and then this angle right here is 180. So I'm going to go 241, subtract 180, 60. So this bearing is south 61 degrees west. Right? Look at C. The next one is 123 degrees 48 minutes. Well, it's less than 180, greater than 90, so that thing is going to be down in this range. So this is 90, this is 180, this is 123, 48, and that bearing. So what I'm going to have to do is I've got to calculate, I'm going to have to calculate this one, right? Because it's got to be from north-south. So that's going to be 180 degrees, and I'm going to subtract 123, 48. I'm going to have to, so 79 degrees. I borrow 1 degree, which is 60 minutes. Remember, you got to remember to do that. And if you borrow a minute, you got to remember it's 60 seconds. So it's,
So 1 degree always equals 60 minutes.
yeah, 1 minute's always 60 seconds. So when you subtract them, you're going to have to remember to do that. Okay, so, and then this is 6. So it's 56 degrees. So this is going to be south 56 degrees, 12 minutes east. D is 329, 29, 25. So it's going to go north-south. And 329 is straight out this way is 270, right? This is a 270 degree. So 329 is going to be a rotation that comes around and puts you up in here. So the angle then that you want to get is going to be this angle, because you're always going north-south. So that one is 360, and then you're going to go 329, 25. So this is 359 and 60. So it's 35 and 30, right? So this is north, 30 degrees, 35 minutes west. And I got to always kind of think about it, and sometimes I even have to look north and say, is west to my left or to my right? Because sometimes I'll forget. But when you're facing north, west is left, east is right. Okay. All right, does that make sense? I think you should draw, rather than try to figure it in your head, I would draw some things like this out, especially when it counts for points, unless you really got a good concept of it. I guess I never, when I'm doing problems like this, I never not draw it out. 38. It says, given the bearing of AB and BC as shown next. So it's that one at the top of the page there. Determine the measure of angle ABC. Be careful with the order of points here. The bearing of AB is not the same as the bearing of BA. All right, so So this one is north 77 degrees 15 minutes west. And then this one, this is C, this is B, and then this is A. And then this is south 27 degrees 47 minutes west. And the question is what's this angle, right? Okay. So this red one, it says north 77 degrees, 15 minutes west. Well, the only thing that makes sense there is that if you draw a north-south line through there, and you say that this angle, this is the angle that they're measuring, north 77 degrees, 15 minutes west. And then that other one is south 27 degrees, 47 minutes west. Well, the only thing they could be doing there is, let's see, that would have to be that angle, right? 27 degrees, 47 minutes west. Now, if you kind of extend this line out, extend this thing out here, then this angle right here, this one right here, is the same as this angle right here, right? Two parallel lines cut by a transverse, the corresponding angles are equal. And then this green line and this green line are equal. Or you could say, right? So this one right here is 27 degrees, 47 minutes. And this one is, what you have is you have a 77 degree, 15-minute angle. And then a 27 degree, 47-minute angle. To make this angle right here.
And then you would just add them up.
Add those two together. 77 degrees, 15 minutes, 27 degrees, 47 minutes. So now you've got 12, 1, 1, is that right? Got it right. And then this is 14, 104, and then you take degrees out of those minutes. So you take 1 degree out, so that'd be 60 minutes. And you'd have 52, and you'd add 1 here, 1 over.
So it's not 112 seconds.
It's 62.
Oh, is it 62?
Yes.
Oh, I wrote that as a 9, huh?
Yes.
Okay. Well, that's 2.
So 105 in 2 minutes.
Can't read my own writing. And then you look back at that angle, it probably, that angle's probably 105 degrees, 2 minutes. But you always want to, take minutes out to change, to add degrees, don't want to leave. Same way with seconds. If you've got more than 60 seconds, you want to take it out, take minutes out. Okay. So any questions on that? Now, I want to look at 42, and this, they're talking radian, and when you do radians, let's see, draw something that's but just grant me that's a circle, and that the it's the radius is this, right? From the center out to any point on the circle, right? Any one of those things should be a radius. Well, 1 radian, if I start here and I lay out that radius length on the circle, then that distance right there is 1 radian. One radian. So, and I forget which mathematician discovered that no matter what the size of the circle is, if you take the diameter and lay it out on the circumference of the circle, it's always pi times. Pi times the diameter is the circumference of the circle. Well, radians is just twice that. So if you measure radians, then there are pi radians there. And there's pi over 2 radians here. And there's 3 pi over 2 radians here. And there's 2 pi radians, one revolution, where a pi is approximately 3.1416, or sometimes use 22 sevenths as an approximation, but that's an approximation. But that's what radians are. And radians are used so that you can do trigonometric functions, and you can do, so you can lay the radius out on a number line and do sinusoidal curves, sinusoidal waves, if you remember from trig. So and it was a unit circle and all that stuff. So just as a review on the unit circle, it's asking you to do on a unit circle lay out made this sufficiently big enough. I gotta get over there. So what they're doing is they're saying that 42, it says use a compass and draw a circle such as the one shown centered on a set of axes. Use a protractor and measure the following: 30, 45, 60, 90. So if we do 30 degrees, 60 degrees, 90 degrees, then we do 45, degrees, and then they want to go on around. So 120, 150, 180, and then this would be 135. They got 225, 270, and then 350. And they want, it says, find each angle marked in degrees, identify the radian measurement, and express it as a fraction in lowest terms. Well, if you recall, you remember from trig, this is pi over 6, this is pi over 4, and this is pi over 3, 2 pi over 6, pi over 3, and then this is pi over 2. Now, so pi over 3. Myself confused when I tell you 6. 2 pi over 2. So it's 2 pi over 3. It's 3 pi over 3, which is 1/2, and then this is 4 pi over 3. And then this is, if you go 45 is pi over 4, then 90 is 2 pi over 4, and this one is 3 pi over 4. And then this one is 5 pi over 6. And then this is pi. And then this is a pi over 4 greater than pi. So if you go 5 pi, 6, 7 pi over 4, 8 pi over 4, and then this is 9 pi over 4. I'm doing something wrong. Pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7. 7 pi over 4, and then 8 pi over 4 is back on itself. Does it say 360? Yeah. 360 is 2 pi. So that's your radian measurement. And if you remember from trig, degrees is a specific unit, but radians is a pure number. Radians does not have units to it, although you might say it's radian, but it can be actually laid out on any circle. It's just telling you how many radiuses there are. And then you can lay it out on a number level and do all your trig functions on it. So this was A. 30, 42. Okay. It says two angles are complementary. One of them has a measure of pi over 7. Find the measure of the other angle. So they're complementary. They add to 90, so they add to pi over 2, right? And one of them is pi over 7. So B, it's pi over 7 plus an angle equals complementary pi over 2, right? So x is going to equal pi over 2 minus pi over 7. So you got to get a common denominator, right? You're going to have to get 7 over 7 and 2 over 2. So then you're going to have a common denominator of 7 pi minus 2 pi all over 14, which is 5 pi over 14. So that would be what the angle is. Then it says C part, one angle measure is twice another. The angles are supplements. Find the measures of the two angles. So one angle is x, the other one is twice x, and they're supplements, so they add to pi, right? So 3x equals pi, x is pi over 3, and so 2x is 2 pi over 3. So there are your two angles. And if you look at it, if you come up to pi over 3, you know, I wrote that wrong. I wrote this wrong. This is pi over 3. Sorry. And this is 2 pi over 3. Because then that makes this down here 3 pi over 3, which is pi. So if you get pi over 3, 60 degrees, and then there's 120 degrees left to get to 180, that's 2 pi over 3. Well, that's a good thing I did that problem. 60 degrees is pi over 3. 30 degrees is pi over 6. So I did that much right. Sorry. Okay.
Professor, how do we determine which angle is pi over 7?
Pi over 7. It's just saying any angle is pi over 7.
Okay?
What this is saying is that there's an angle that's pi over 7.
Okay?
And the sum of the two angles are complements. So they would sum to 90, and 90 degrees is this.
Okay?
Pi over 7, I don't know. See, we know exactly what pi over 6 is. Pi over something 7, that's
So you
pi
really
over,
don't
pi over,
need to know.
no, you don't need to know, you just radians. But the sum, we know that if they're complements, these two are complements, then they add to 90 degrees, right? 90 degrees, and 90 degrees is pi over 2 radians. So if you know one angle is pi over 7, and then you add an angle, then it's got to add to pi over 2. See, because pi over 2 is 90 degrees. And then this problem was supplements. So they add to 180, and that's 180 degrees. Supplements. This is complements. Have other questions? Okay. Just I'll look a little bit at the next section 2.2. We all know what triangle is on page 52. And then there's different kinds of triangles down at the bottom of the page: equilateral, all sides equal, isosceles, congruent. Now congruency means they're equal. When angles are congruent, they're equal, sides are congruent, they're equal sides. Isosceles, two sides of the triangle are congruent. Scalene, no sides are congruent. An acute one means all three angles are less than 90 degrees. So we've gone from sides to angles. A right triangle is one angle is 90. Obtuse, one angle is an obtuse angle, and then there's equal angular. Notice at the top is equilateral, all sides congruent. Equal angular is all angles are equal. Now, all of those are unique when you have the sides congruent and whatever it is, except the last one. If you remember from your geometry in high school, when you have an equal angular triangle, that don't describe a unique one. But if you have an equilateral, there's only one equilateral that has a certain length side. All sides are the same. But you can have an equal angular, and then the triangles don't have. When you were proving congruency of triangles, remember that. All sides congruent, there's unique. They're congruent to only one. But when you had angle, 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 you couldn't prove congruency. Isosceles, the base angles are the angles opposite the congruent sides, and then the base side is the one that's between the two congruent sides. And the vertex angle is the one that the two congruent sides attach. A right triangle, the hypotenuse is opposite the 90-degree angles. The others are legs. Simple closed figure cannot cross itself and cannot retrace. Anything that does that, you notice it can be circular, or it can be, a polygon. It's going to talk about a circle, center, radius, diameter, radius center out to the circle, diameter, any line joining 2 points on the circle through the center. Okay, well, I guess our time is up. So